Okay, continue with multiplying and dividing radical expressions. If you see something like this where we are dividing, we compare numbers that are both inside and outside the radical. So they're both inside numbers, so they can be simplified together. We can also see it as like one big radical over here, and you divide first and then see what you're left with. So we get 32, so it's the square root of 32, and then we simplify. So if they're both inside the radical, inside the house, they can play together, and then after that you want to simplify. So 4 and 2, you can stop here as well, because if you notice, we've got 2 4s, so you actually might not even have to break it down all the way. You notice 4 has a buddy, so it can leave the house. If you want to break it down even further, you'll get at the very end 4 that will be able to leave the house, and I've got the 2 that's still there, so it's 4 red 2. If you got something a little bit more involved with your dividing of your radical expressions, you still want to follow the same thing. Are we working inside of the house or outside of the house? So 18, yikes, 18x to the 5th divided by the square root of 6x. They're both inside the house, so they can play together. And I want to simplify that first and then see what's left over. So for 18 and 6, it's 3 and 1. And x to the 5th, that means 5x's up top, 1x on the bottom. I'm left with x to the 4th and a 1 here. So I don't have anything in the denominator. I just have 3x to the 4th. Okay, so 3 is just 3 and 1, so it stays inside the house. But x to the 4th, if I look at x to the 4th, divide that by 2, that means 2 of my x's are going to be able to leave the house. So it's x squared, and I had no remainders, so there's no x's remaining in the house. And I've got a 3. So it's x squared, square root of 3 for our final answer. Third example, bigger numbers, same process. Square root of 225 x to the 10th over the square root of 3x to the 3rd. They are both inside the house, so they can play together. So I'm going to write it all under one big house, one big radical. And I simplify, just looking at my fraction, that's it. 225 and 3. So I get 75 left over, 1 on the bottom, and then x to the 10th, x to the 3rd. I've got 10 x's on top, canceling with, and then 3 x's on the bottom. That means I'm left with 7 x's on top. So I have the square root of 75 x to the 7th. And I definitely need to simplify that. So let's look at 75. 75, I would say it's like 3/4, right? 75 cents is 3/4, so it's 25 and 3, 5 and 5. 5 has a buddy, so it can leave the house. So at the very end, I'm going to move over here. I'm going to have a 5 outside the house and leave a little space because probably something else is going to be there. And I've got a 3 that didn't have a buddy, so it stays inside of the house. X to the 7th. X to the 7th. With our variables, we divide our exponent by 2. And 7 divided by 2 is 3, remainder 1, meaning 3 x's can leave the house, and 1 remains in the house. So x to the 3rd, 3 x's outside the house, 1 remains inside of the house. And that's my final answer. So fractions and radicals, we want to deal with inside of the house versus outside of the house first, and then simplify.